Okay, so the kids figured out pretty quickly that A was the one that was different. And I told them it was because it was y equals x squared. Wait a minute, no. 1 over x squared. 1 over x squared is a graph that you're not even going to learn until next year. I call it the volcano. See how it kind of looks like a really tall mountainy shape? All right. But then I said, of the remaining graphs, of the remaining 3, one of them is still different than the other ones. Which one's different? Yes?
The one in the bottom right.
Yep. Do you guys get that this has something up in the upper right, and this one has something in the upper right, and this one doesn't have anything in the upper right? So it's kind of like reversed. What that comes from is if you take the graph of 1 over x and then you flip it. Do you remember what thing makes a graph flip? Yes, a negative. So if I put a negative like this, my graph that would have been here and here, that's the 1 over x graph, flips and it turns into here and here. Changes from the red one to the blue one. Do you get the difference there? If you put a negative on it, what really happened is this one flips down to here and this one flips up to here. The negative makes the thing flip up and down. Or you could think of it as flipping left and right. Because look how there's something here that kind of could flip over there. So you could think of these as flipping from left to right. Either way, a negative makes something flip, and the official word for flip is reflect. That's the one thing that we hadn't talked about yet. I gave you problems like this, and I said, what if we did like a plus 3 here? And most of you guys knew that was up 3. You remember that now? Okay. And then I said, what if I put like a minus 2 here? And most of you knew that was right 2. Kind of the opposite of what you would think. You would think it'd be left 2, but you don't trust the stuff on the inside, so it's right 2. Then the last thing I got to do is, what if we put a negative on it? Well, then the whole graph flips. Let me show you what that would look like. Let's just do this graph in the first place. Everybody, please write this down. And then I want you to take little notes off, like this is right 2. And this is up 3. This has a x equals 2 vertical asymptote. This has a y equals 3 horizontal. Do you remember me saying horizontal? It's just a dumb way to say horizontal with a y in it so that you connect y with horizontal asymptote. So this number here tells you the horizontal. That's like the horizon. It's a dotted line that goes like this, that kind of asymptote. This on the bottom tells you the vertical, and that's a vertical line like this at x equals 2. And it's whatever makes the bottom 0. If I put a 2 in, I'd have a 0 on the bottom. And you can't have a 0 on the bottom. That's why we get an asymptote. All right, there's the big picture. And the last thing I taught you was if I give you an XY chart, you better be able to find me some points. So I'll rewrite the graph here. Y equals 1 over x minus 2 plus 3 on the outside. And I'd like you to stick in 1, 2, and 3. And one of these 3 things gives you the asymptote. So you can just write asymptote. Stick in x is 1. See what y equals. See, it says right here, y equals, and then the x is over there, so you stick the x number in where the x is. Dasho, if I'm going to stick in the 1, where am I going to put it?
Where the x is.
Good, so I put a 1 right here. And then can you in your head do 1 minus 2?
Yep.
What is it?
-1.
And then I go 1 divided by -1, and what do I get?
-1.
-1. And if you can't do -1 plus 3, I guess you'd be toast. But you can use calculators in this class, so we'd probably even have a calculator handy on this. And you just go -1 plus 3, and y equals 2. So then you put a 2 right there. Do you get how 1 turned into 2? That's a point, 1 comma 2. That's one of the points on my graph. And I did it a really slow way in the very first one we did, and I showed you like we graphed like 6 points. We kept on sticking in numbers and getting a dot. Stick in a number and get a point. So would you please put in 2 now, everybody, in your head? This 2 right here. We're sticking a 2 in. And what do you have? 1 over 0? What the heck does that mean? That's the asymptote. When you have something over 0, you have found the asymptote. And now I know these are confusing. Which asymptote is it though? Well, the x equals 2, I gave you a way to remember it. Zertical. X is like the beginning of the word zertical, because that's the vertical asymptote. And this one then is the horizontal. Asymptote. Okay, so that right there, wait a minute, I just wrote y equals 2. I'm so sorry, that's x equals 2. It says it right above it, x equals 2. And that x equals 2 gave us the, what kind? Zertical. The zertical asymptote. The vertical asymptote is x equals 2. And then if I stick in 3, 3 goes here, and then I got 3 minus 2 is 1, and then I got 1 divided by 1 is 1, plus 3 is 4. Who had 3 comma 4 before I ever said it? All right, awesome. Now the final big hoo-ha, what you do to finish this problem is, you go x equals 2. You remember this thing? It's the thing that makes the asymptote, x equals 2. Here's where x equals 2. Here's y equals 3, the horizontal one. That goes through like this. At 3. That's where y is 3. This is where x equaled 2. And then I know my graph, they always kind of look like this. Do. Have you gotten used to that little pattern? Like where I just put the red lines? That's what the graphs look like. But I need a few points like 3 comma 4. See, this is 3 comma 4. And this point is 1 comma 2. I bet you that's this one. Yup. Over 1 up 2. It's all matching up. And then I said this had asymptotic behavior because it gets closer and closer to that line without ever touching it. And the same thing with this line. It goes closer and closer to the asymptote line. There we go. That's how to graph, and that's what your test is like. And your test is on Friday. Today's Wednesday. That makes tomorrow the review day. Okay? And the only thing I really hadn't talked over with you is those negatives in the front, which make everything flip. What if we had a negative in the front of this one? Then the whole thing would flip. And let me show you where that would go. This line here isn't here anymore. It goes here. And this line isn't here anymore. And it goes here. Do you get how the blue lines are kind of related to the red lines? They're just a flip. All right. So let's run through some various different test questions. And the way I'm going to think of today is like the first review for the test. And then tomorrow is the last chance to review for the test. And then Friday is the test. All right. So everybody get this page of the notes. Make sure that you get what horizontal and vertical mean. Remember, we're not going to do oblique. That's for the honors class. Horizontal is like horizon line. But it's really important. Is that an X or a Y? I gave you a dumb little word to remember it. What was my dumb little word that helps you remember horizontal is X or Y? Horizontal. Good. So put a Y right here, everybody. And you'll know, oh, these are those Y equals lines. The Y equals ones are the ones that go across. And vertical? vertical, because those are the x equals lines. So this could be like x equals 2 or something like that. The dotted lines that go up and down are the x's. The horizontals are the horizontals. So this line might be like y equals 3 or something. Okay? Next page. Notice horizontal asymptotes are a dotted line and you never cross it. I said it was kind of like a electric fence. So when your line gets closer and closer to that, it's kind of like you get closer and closer to an electric fence, but you would never want to touch the electric fence. Same thing, the asymptotes never actually get there. It's kind of like saying if I took $100 and I said, okay, I'll give you half of it. Well, that'd be 50. What if I said I'll give you half of that? Well, that'd be 25. No, I'm only give you half of that. Well, then it's 12.50. If I keep cutting it in half forever, you will never get to 0. You might get down to like a penny and then half of that. It's a hay penny, in case you didn't know that. Back in the day, things were so cheap that a half of a penny would actually buy you something. There's some people that theorize that our prices are eventually going to get so expensive that a penny won't be meaningless. It'll be meaningless. Like, who cares about a penny? I mean, like, what's the last time you ever bought something for a penny? It's pretty rare, right? So would you agree that in your lifetime, pennies might just go away? Maybe dimes would be the smallest thing that there is? Very possible. Nickels and pennies could both go away. Do you think you'd even miss them if you didn't have a penny or a nickel? I wouldn't miss it. That'd be fine. Just round everything to a dime. Now, I know some things, though, that are super cheap. Well, when they just sell you like 10 for a dime, you know what I mean? Instead of having a price that's a penny, they can sell you 10 of them. Okay, so anyways, which one's which again? Everybody don't say it. Underneath this, write an example of an asymptote. Is this the x or the y one? And is this the x or the y one? Like, is this x equals 6 or y equals 6? Is this x equals 6 or is it y equals 6? Vivian, which one is the horizontal one? It's the horizontal one. Good. It's like that one. Not like that one. And the vertical is like the x equals, so it's not this one, it's that one. Okay, good. So then, if I show you a picture, I'm hoping you can say, I see the two dotted lines. One of them's blue, one of them's dark gray. And you should be able to tell me what they are. I'll give you a hint. This is a horizontal one, so it's y equals something. Everybody off to the side over here, write y equals something. And underneath this one, x equals something. But what? Well, you can look on the graph and see what it is. I know the graph's a little sketchy. That's pretty bad, in fact. You see how this is 2 and this is supposed to be a 4. They're supposed to be numbering by 2's here. And that's -2. And that's -4. The numbering on these is pretty bad. That's a 0. Okay. How many of you knew this was y equals 0 right there? You get that? It's going through 0. Here's 2. It's going through 0. And here's -2. So y equals 0. How about x equals? It's right there. It's right on the line. X equals -2. Do you get? I've got my asymptotes now. Is this vertical or horizontal? Say it. Vertical. This one's horizontal. Okay. If I get to this one, there's two dotted lines, a black one and a blue one. Would you please label this with something equals something, and label this blue one with something equals something? Like x equals 3, that kind of thing. Label the asymptotes. Now, it's important for you to actually try this and then compare it with the kid next to you, because otherwise it's so easy to just get them confused or watch me and it seems easy till you have to do it. Okay, just to clarify some numbering, this is a 5, which makes this a 4, 3, 2, 1, 0, -1, -2, all the way up to -5. And then here, that's where +5 is. So this is where +4, +3, +2 would be about here. +1 would be about there. That makes this -1 and -2 and -3. I think you get the idea. So everybody figure out what those asymptotes are. And I'm going to ask you to compare them with the kid next to you. This and this. One's X, one's Y. Careful with your numbers. Okay. So there's vertical and there's horizontal. The way I go through this in my head is that's a horizontal line. It's like the horizon line. So it's horizontal, which is horizontal. Y equals -1. Raise your hand if you had Y equals -1. Okay, awesome. How about the other one then? Well, and I like to talk it through and I go, it's vertical because it's up and down. That's like Michael Jordan's vertical. Back in my day, he was the best basketball player, so I think of him. We go up and down, right? So vertical is up and down, so that's like zertical, X equals. And what number is that at? Well, here's all the X numbers, and it's at X equals 0. Who would have been able to name that one properly? Okay. Questions or comments? Anything? All right. Then let's move on to the next page. If you had to just describe what's happening to this in words like right, left, up, down, this first one, I'll help. It would have been right 1 and up 2. You could have said that in either order. Could have started with up 2 and then said right 1. Would you please tell me the others? What is this? What's this? And what has happened with this negative here? What is that called? I'd said it once this hour. Let's see how good your short-term memory is. The not official word would be okay. What does it do when you put a negative on something? If you can even think of the like slang term for it, I'm good with that. Trap down.
Is it a reflection?
It is. It's called a reflection. The slang term is flip. I would have accepted either. But on a test, try to remember reflect. And then this other one, what is this 3 here, Davis? Left 3. And what's this -2? Say it if you know it. Down 2. Any questions on those? I think they're fairly easy. Okay. This is just a plain old-fashioned, simple, like the test is just like this. So how would I do it? I go figure out my X equals a horizontal, vertical asymptote. And then I'd figure out my Y equals asymptote, and that's the horizontal, and then I'd put them in. I am on purpose not putting them in the right spot, but you'd go put in your asymptotes in the right spot. And then I'd list them here, like X equals 3 and Y equals 2 or whatever. Those are not right. But then I'd try to graph a point, like on an XY chart. And I'd think, I wonder which number I should stick in. If I stick in a 1, oh my gosh, I got an asymptote. So I won't use that. That's not a point. And then I'll stick in 2, maybe stick in 3, maybe stick in -1. Just stick in a few points. Then graph it, and it should look something like that. This is not the final answer. You have to know where all these things go. So do your asymptotes first, then pick a couple points, and then we'll see who graphs this in the right spot. If you get stuck, please raise your hand. Let me help you. So while you're checking with that other kid, did you guys know I was hinting that this was Y equals 2 right here? And that this one was X equals 1? Who had X equals 1 and Y equals 2? Good. Now put them on the graph. X is a vertical, so it goes at 1, right through the 1. Remember how I said it moved to the right a little bit? See, it moved to the right a little bit. And then Y equals 2 goes like this. Now you got to find a couple points on your XY chart and then do asymptotes. or sorry, then draw the asymptotic behavior from those points. Giving you a second to find a few points. Talk to the kid next to you about what goes here and here and here. Pausing. Okay, so here's how this should have gone. Vivian, when you put in a 2, that's this 2 right here. You put a 2 right there. And then walk me through it. What do you get for this part?
I just used my calculator.
Okay, and then when you got it all done and you got -1 plus 2, what did you get? Pretty sure it's 3. You are correct. Good job. 2 comma 3. I'm going to go over 2 and up 3, and look at that. It's, to me, that point seems perfect, because you know how it then goes like this, everybody? All right. Rena, tell me what you got when you stuck in a 3. 1 over 3 minus 1 is 2. 1/2 plus 2 is 2.5. Very good. So over 3 up 2.5. That's right here. I kind of missed it a little bit, so I guess I should have made my asymptotic behavior go down a little more right there. And then it goes like through there. Okay, really close to the line. And then last but not least, we put in the -1. Eli, when you put in -1, what did you get?
I didn't do -1.
Okay, I'm going to work it through with you then right now. What's -1 minus 1? It's -2. And then I have 1 over -2 means -1/2. -1/2 plus 2 is 1.5. Okay, I agree that's not actually an awesome point, but it's a point. And I'm going to go to -1, comma 1.5. Wait a minute. I think that was negative. Nope, it's not. Oh, there it is. Okay, -1, comma 1.5 is like right there. And you know what, guys? That would have been good enough, because from there I can just do asymptotic behavior and get closer and closer. That would have been good enough. You could have done another point. Did you do a different point?
I did 0.
And when you got 0 plugged in, what did you get?
I got 1.
0, 1 would have been a great point to graph. 0, 1 would have been right there. I missed it, but I was really close to it. Okay, so there's what your final graph looks like. You know these are not easy because it requires like 4 skills on each problem. You got to know where the horizontals and the verticals are. You got to know the difference for x and y, which one's which. And I keep telling you vertical and horizontal so that the y goes with horizontal. You got to be able to find points like this. You got to be able to graph points. And you got to be able to make lines that get closer and closer to the asymptotes. It's called asymptotic behavior. Lots to know. All right, everybody go to this page. And really fast, right off the bat, I can go x equals negative what? Nope. X is this one right here. X equals what? -3. And that's the, is it the vertical or the horizontal? Hopefully you'll figure it out. And this one's y equals -2. And hopefully you'll know if that's horizontal or vertical. And then I'd go make my asymptotes. Put the dotted lines on here, you know. And then I would figure out a couple key points. Do it. Your job. Pausing while you try that. We're almost done, guys. If you can just do this and then occasionally flip your graph over, that's the only really tough thing. I think you got this. How do I get the x equals line on here? Is the x equals thing here going to be a vertical line or a horizontal line?
X is going to be vertical.
Good. And it's at -3, so I'm putting it right here. Did you do the same thing? Excellent. And that's this line. And how about the y equals line? Tell me if I did this right. Does that feel like where y equals -2 should be? All right. And it's horizontal. So that is like a horizontal line, right? Okay. And now I just need a couple points. And I bet you those points are probably going to be right here and right here. If you've kind of got used to this pattern, that's probably where they are. But let's figure out exactly. I'm going to stick in a number. A random number? No, I'm going to be smart. I'm going to make this come out to 1. So I'm going to put in a -2. You see how I like strategically planned that? I didn't just pick a random number. I stuck in -2 on purpose because I knew the bottom would come out to 1 then, and 1 over 1 is 1. 1 minus 2 then, 1 minus 2 is -1. Did anybody else get -2, -1? That was a good call. Okay, here's where -2, -1 lives. It's that spot I kind of predicted. Right there, -2, -1. Okay, and now how about another point? You get to pick anything you want, but personally, I would always pick something that works nice, something easy. So I'd pick something else that's like would work nice right here. Who has a suggestion? You tried it and it worked pretty good. -4, good call. Because -4 plus 3 comes out to -1. And 1 over -1 works really nice. 1 over -1 is -1. Minus 2 makes -1, minus 2 makes -3. So when we stuck in -4 right here, see, -4, we got -3. That's probably the hardest part, is finding these 2 points. Because I bet you most of you guys can make this line now that goes closer, closer, never touches. Closer, closer, never touches. Does that make sense? Now, what's the one thing I keep saying is like, the only other thing we could do is what? We could reflect this thing. If we had stuck in a negative, if we had a negative in here, then do you get it would change to here and here? It'd be the blue one, not the red one. If there was a negative in the equation, if they had stuck a negative right in the front of this whole thing, like one extra negative right there, means everything would be the opposite, and all the y's become the opposite. And if they were like positive, now they become negative. So then it changes from the red one to the blue one, if you stuck a negative in the problem. All right, I think you've learned everything. This has got one of those negatives. So if I wanted to just say, well, generally they look like this. That's generally what the graph should look like. I almost could get credit for that, except that it missed this point right here. So I really ought to get my XY chart and stick in like a number like 1 and see what I get. And I get -1, and that was here, right here. But maybe I should put in -1, and then I'll get -1 over -1, which would be 1. -1, 1. Oh, so this whole thing has to be flipped like this. There we go. Okay. Now I think you'd be best served by doing some problems off the worksheet and then coming up and asking me when you get stuck, because it's really hard to like tell a group how to help when you get stuck. You need to walk up and go, I'm stuck. But you also need to be able to feel free to ask the kid next to you. If you're both stuck, maybe you should come up together, okay? So there is only one of me, and if there's nobody asking me a question, come up. But if there's like a big line of 3 people, then ask the kid next to you, like, did you get this? All right, so let's look at the worksheet together. Everybody find the worksheet. Understand if you have to go, you have to go. Pausing.
Equals 1 over x.
Well, that seems pretty easy. And then, what are you supposed to do? Just graph it?
Yeah.
Oh, well then right off the bat, I would just go, the asymptote on the bottom is x equals 0. Because if you stick in 0, you get 0 on the bottom. There's nothing here, so I'm putting a plus 0. So y equals 0 is the other asymptote. And maybe you just memorize that they go like this. And then you get 1 point here, and 1 point here, and then asymptotic behavior. There we go. First one's done already. Get that on your paper. That's your first one. Okay, now I need to go look at some of these so I can see how many to skip here. All right, today's is the first in a long time where if I have you skip anything, it'll actually hurt you a little bit. And the assignment is so short. The big middle section of it is just like, which way does this move? Okay, so this should be easy. Crank this puppy out. You should be able to finish it before you even walk out of here, even though it's a short day today, because it's a math day. So you just have to understand the thing about asking questions. If you don't ask questions because, like, I don't want to look dumb, that is dumb. Just ask, because it's the kids that get the best scores that always ask me the questions. It really is. That's not a sign of being dumb. It's a sign of I actually want to do this right. Okay? So don't be scared to ask me questions. And that's all I have for you for the video for today.